Good afternoon. Good afternoon, everyone. Today we are having a session on RAG, that is Retrieval-Augmented Generation. We are taking this session for the students who are learning NLP at our MIT ADT campus in MTech CSC course and program, and they have got a subject of natural language processing. So RAG is a model which is used for segregating the context in our CFG grammar. So we'll start the session with some basic fundamentals, and maybe in the next audio video, we will try to compile that using a research paper so that it can be understood better. So basically, retrieval augmented generation. Now, when you are using NLP, so if we are focusing on sentences, in NLP for text processing, we first segregate the words into lexicons. We create a lexicon where we add the syntax in the form of CFG, context-free grammar. We already have a session on that earlier. You can look on the channel. And similarly, we attach a semantics in the lexicon table. So every word segregated. Okay, we have to remove these stop words. Okay, for example, is or to, such type of stop words we need to remove. That's called the dispensable words. And only the indispensable words like verbs, nouns, adjectives, which create the meaning to the sentence. So that we convert into lexicon. So lexicon attributes, and there is a lexicon table which consists of these words, the semantics, the syntax. So we need to understand the finite automata theory for creating the context-free grammar. So all these topics are earlier taken for this particular subject. But if you want to really understood what RAG is, so even though we segregate the words, when we combine together, NLP is basically, we need to do the text processing without any ambiguity. So LLM, which you are using nowadays, for example, ChatGPT, you want the answer without ambiguity, but there is a lot of ambiguity in the same words or the prompts which you share, correct? So internally, there is a lexicon, then context-free grammar, then RAG model. So RAG model focuses more on the context of your prompt. So it tries to ask you certain questions so that it gives you more unambiguous answer, because internally the LLM itself is ambiguous. So it himself is ambiguous, and that is why it may give you the answer which it may not be apt for you. So it tries to guide you in that particular manner. So I hope through this I'm able to make you realize what is the importance of RAG. So it is in the form of a tree data structure. If the tree is closed, then it is called as a graph. So basically, the RAG optimizes the LLM by fetching relevant documents or data from sources like vector databases before generating answers, avoiding reliance solely or pre-trained knowledge. Fine. So we have got vector databases. So it is collecting the data from sources like vector. Now, what is vector databases? Correct. So, for example, if I have a sentence where I say, I love my dog, finally, you try to segregate the words as love, dog. But if you do not understand the context, that I'm talking about myself, but you may take the data from the vector databases of animals, because dog is the word being used there, and you start focusing on the dog's characteristics and everything, and you just forget the context that it was about me. I love my dog. Okay. But so vector data about the dog, there may be a vector. Vector is a related documents about a particular concept. Okay. So the dog is an animal, that's a concept. But love is another concept. So what is the emotion in this particular sentence is a positive emotion called love. Okay, so depending upon your prompt, fine, it will take the data, but finally it will take the data of its the verbs, adjective, nouns. There are different related contextual vector databases. Finally, when it's consolidated and gives you the answer, the RAG will help him, okay, to understand the segregating, that means synthesis. Analysis is breaking up, and then synthesis, getting it combined as per the context. So the key components of that data sources will be your external documents, correct? Which you can take from Greeks for Greeks, which is very famous for collection of documents. You will getting embedded vector databases for similarity search, again Greeks of Greeks. Then you can retrieve documents from relevant chunks based on query vectors, so that you can get from blogs.nvdi. And I can just share you this document in the description box, and then the link where this is shared, my SlideShare channel, and then you can download this so you'll get the relevant links as well. So, and you can get the generator LLM also, that uses relative context plus the prompt. So that data is stored in the research.ibm. So these links have such retrieved context um, links from where your LLMs searches data from your prompt. So what is the workflow steps? The chunk and embed external data into a searchable index. Fine. So one concept, first we learned that what is RAG, what is the importance of RAG in NLP. And of course, this RAG is also used in LLMs, which is today a very Gen AI used model without which we cannot live. What are the external resources? The key components that is given to you in this particular presentation. You can go through that in detail. Okay. And what is vector databases? I gave you the example of I love my dog. So love is an emotion. So it will have emotion vector databases. Dog can be of an animal vector databases. Vector databases is collection of data. So for example, array in a data structure, correct? So it is a homogeneous data type. Then we have got a structured data structure in C, C++. So that is a heterogeneous data type collection. Okay. One step ahead, we go to object databases, that is object-oriented languages that use data structure class, which is again a combination of arrays and structures. So it is again a combination of homogeneous and heterogeneous. Finally, we have got landed to a closed graph, sorry, closed tree, that is a graph, and context-free grammar again as a tree and graph data structure. Correct? So that is the RAG model. The concept is that we need to not only understand the words, the semantics, the syntax in the grammar, because where we are using RAG, one of the applications is NLP. So natural language communication processing. So language. So for language, you've got communication, right? So if you use English language, so the sentence is I love my dog. In that way, the words will be reframed into lexicon, the semantics, the syntax, and finally the context for which RAG is used to remove redundancy and to not lose your context behind the entire syntax or your prompt. Correct? So we remove the ambiguity more and more and get you the precise data needed. So even that ambiguity will be resolved when you more and more give that prompt to the user, and it will be able to guide where you can get the apt data sources as mentioned in this section. So workflow steps is the chunk and embed external data into a searchable index. So what it will do, first it will take all the data set, and how the RAG will be created. The workflow steps is first that you have to convert that external data into a searchable index. So if you use a tree type of a data structure, it will help you to segregate your words into more specific, subparents. And you can create one index on one row of the tree. And likewise, you can search accordingly. So you can have a row major form or you can have a column major form. Okay. For example, if I can just so this is the tree type RAG model. You all know what is tree data structure if you are a computer engineering student. So we have got a root, then we have got a key attached. So this can be our indexing key. We will have edges, correct? So you can have your indexing this way also, or you can have your indexing this way also. Okay, so this will be the height of the tree. These are the leaves, these are the subtree. So this can again be a vector, subvector. This is one vector, this is one vector, this is a subvector. So this is how your LLM, what you are trying to create. Okay, so this way you can store the data. What I wanted to is it can be a row measure form representation of data or a column measure form. So that can be one of the way, okay, to represent it. So finally, we come to the second step, that is convert user query to a vector and retrieve top matches. So whatever query it will have, it will go to the particular tree. Okay, that sub vector which I explained. So accordingly, it will use the key and it will see which are the top matches, correct? So, and then third is augment the prompt with retrieve info and generate the response. So augment means you will land up to that particular node, okay, the child node, and what that node is attached to Greeks for Greeks, because this is right now most frequently used for documents. So every node, there will be a Greeks for Greeks link attached to it. There will be a key attached to it. So finally, you will retrieve that document, okay, from that node, which is called augmentation. So what will be the benefits of the RAG? It will improve the accuracy. It will reduce hallucinations and handles proprietary or up-to-date info efficiently. Why? Because time to time, this LLM is being handled by external databases. So Greeks and Greeks, okay, it is periodically uploading the data as per hot searches, and it is also used for chatbot search and enterprise. So there basically what external database these the LLMs are using, that is the Wikipedia, and of course the other three links you can go into detail. So for this second step, that is convert user query, okay, to a vector and retrieve the top matches, the LLMs tops internal model which is being trained is by Oracle. Okay, so this is a short session where I just explained you what is RAG, the importance of RAG in NLP, LLMs, okay, the data structures involved, the key components, the workflow steps, the T structure and its benefits. So I hope this short session on the introduction of RAG will be useful for you to understand and creating to understand the LLMs also. And if you want to create an LLM, that then you can't skip RAG at all. So our next session will be on how does RAG work step by step. So we have already explained in short about those steps. Okay, so for example, the user submits a query. Fine. Then the query is converted into a vector. Then the retrieval finds relevant document from vector database. The system builds an augment prompt, okay, from the RAG tree. The LLM generates the answer. So the LLM's background is the external sources and the RAG model. Okay, and finally, okay, when you land up to the child node and you augment that data, okay, that all will process it for reprompting to get context related to the RAG model to get a better quality and accuracy as per your requirement. Fine. So we will stop this session here. And these are the, I'll share you this document so you can go through these different types of explanation, whatever we discussed in the theory. I'll just give you half a second. You can go through this model as well. This is just another way of representation, okay, of what how RAG model works. You can re-hear this recording and you can even pause the recording just to, note these diagrams in your notes, right? So these workflow, we are going to just reshare in our next video, correct? With a recap and a little bit detail, and following with what are the main components of RAG, and what is RAG versus fine tuning, which is better, that I will be explaining, and how to implement RAG using AWS or Google Cloud. But this will be the next session content. So thank you very much for your patience listening. Have a nice day. This is Dr. Ayesha Butalia signing off for this session on Introduction to RAG and its importance to NLP.